Welcome back to your favorite pre-calculus class. In this section, section 1.2, we're going to look at graphs of equations in two variables. We're going to graph by point plotting, find intercepts, talk about symmetry, and graph some key equations. So let's go ahead and start first by reminding you how to graph by plotting points. If you're graphing by plotting points, let me grab this. First thing you want to do is make an XY table so that you can put some inputs in. Like here's a few inputs, and then you're just going to plug them in one by one. So let's plug in the -2, and you can pick anything. I just like to pick those 5 are kind of nice ones for this line here. So we got -4 plus 5, this ends up being 1. So when I plug in -2, I get 1. When I plug in -1, this time for x, we've got -2 plus 5, which is 3. When I plug 0 in for x, we get 5. I plug 1 in, we get 7. When we get 2 in, we get 9, and so on. Then we just graph that thing. So -2, comma 1, and then we got -1, comma 3. -2, 1, -1, 3. This thing doesn't want to do a dot. 0, 5, and so on, and then we graph that line. It goes right through those points. Okay, so that's just a reminder how you graph by plotting points. You pick some x values, put them into the equation to get the corresponding y, and then plot each xy point. Now let's talk about some intercepts. This here is showing your x-intercepts. Here on the x-axis, right, on your x-axis there. Up here is your y-intercept. So here's an example of a graph with some x-intercepts. If they asked you what are your x-intercepts, you would name these points right there. And then if they asked you what's the y-intercepts, then you would name that one, and that one, right? Those 3. Now, what do you notice about each of those what do you notice about each of these x-intercepts here? Hopefully you notice that their y values are 0. So when you are finding an x-intercept, you got to let your y be 0 in an equation. When you're finding the y-intercept, on the other hand, you're going to let your x value be 0, and that's what this slide here is saying. To find an x-intercept, let y be 0, whereas because the x-intercept lies on the x-axis, and that's where your y is 0. To find the y-intercept, on the other hand, you're going to let your x be 0. So for example, right here, you've got y equals x squared minus 4. So to find your x-intercept, we're going to let y be 0. To find our y-intercept, we're going to let x be 0. Okay, so let's first find our x-intercept by letting y be 0. So let's find our x-intercept by letting y be 0. So 0 equals x squared minus 4. We add 4 to both sides. So we have 4 equals x squared, or x squared equals 4. We square root both sides, and we get that plus or minus 2 there. So plus minus 2. So we have both 2, 0, and we have -2, 0. Okay, those are our two x-intercepts because we have both plus or minus 2 on that. Now let's find our y-intercept by letting x be 0 this time in the equation. So this time x is 0. So it looks like we end up getting y is -4. So there's a point 0, comma -4. Now this thing is a quadratic, you notice, x squared, right? So, and you notice it's symmetrical. Here you have this point 2, 0 over here, you have this point over here, -2, 0. You got this point 0, negative 4. So if you want to plot a few points, you're welcome to. You can throw in like 1. 1 squared minus 4 is negative 3, or negative 1. Negative 1 squared is 1. 1 minus 4, negative 3. And anyways, you got to get enough points that you're feeling comfortable with it. Uh-oh, that's not wanting to draw for me. 1, negative 3, negative 1, negative 3. And then you draw the parabola, square root minus 4. Okay, we'll talk more about quadratics and more later in the course. Graph is said to be symmetric with respect to the x-axis if for every point x, y on the graph, the point x, negative y is on the graph. So here's an example of a graph that is symmetric with respect to the x-axis. For instance, let's say that point right there is the point 5, comma 1. Well, if you got the point 5, comma 1, it's symmetric with respect to the x-axis, so you should have the point 5, comma negative 1 on the graph there. You notice how every point's flipped around that x-axis. So that's symmetrical with respect to the x-axis. If you're symmetric with respect to the y-axis, on the other hand, you'll have every point xy. That means you'll have the point negative xy. For example, here if you've got the point 6, comma 2 right there, and you flip it about the y-axis, you'll have the point negative 6, comma 2 over here. Okay. If you're symmetric with respect to the origin, that means you're going to be flipped about both axes. So for instance, this point 4, 1, if you flip it about the y-axis, and then you flip it about the x-axis, you'll have the point negative 4, negative 1. So both signs will change in that case. Okay. So here's your test for symmetry. If you're going to test for the symmetrical about the x-axis, you replace y with negative y and see if it's the same. If it is, it's symmetrical about the x-axis. To test about the y-axis, you replace x with negative x, and it's got to be the same. To test if it's symmetrical about the origin, you replace x with negative x and y with the opposite of y, and it should be. And if it simplifies to be the original, it's symmetric with respect to the origin. So let's do an example here. Y equals 4x squared over x squared plus 1. Let's see if this is symmetric with respect to the let's do it x-axis. Sorry, I'm struggling with my pen here. So our original equation, y equals 4x squared. How do I get rid of that darn thing? 4x squared over x squared plus 1. Now, if it's symmetric with respect to the x-axis, then I can just replace y with negative y, and when I simplify this, I should end up with the same thing that I started with. Okay. Well, I want to get rid of this negative y, so let me multiply this side by negative 1 and this other side by negative 1. So now I have y equals, I'm going to put that negative in front. And I look at that and I say, is that the original? Is that what I started with? No, because obviously I have the negative in front. So this is not symmetric with respect to the x-axis. And then I go to, so let me just erase all this real fast. Now I'm going to test if it's symmetric with respect to the y-axis. So if I'm testing if it's symmetric with respect to the y-axis, this time I'm going to replace my x with negative x and see if it's the same. So let me replace the x with negative x. And I got negative x squared is just an x squared. So 4x squared. Down here I've got a negative x, and it's also squared. So that's x squared plus 1. And you notice, hey, look at that. That's the exact same thing I started with. So this is symmetric with respect to the y-axis. Okay. Now, if I was testing if this was symmetric with respect to the origin, I would replace y with negative y, and I would replace x with negative x. And then I would simplify, and this is with respect to the origin, okay? And then I would simplify this thing, and I would see if I ended up with my original, which when you take that negative over to the other side, you do not. So this is not symmetric with respect to the origin. So it's only symmetric with respect to the x-axis, or y-axis, as I previously showed. You can see that in the graph here. Notice if you've got this point, I don't know, let's say it's 4, 3 approximately, then you'd have the point negative 4, 3 over here. All right, let's do our last example here. You can graph this by, we're going to do it by initially finding intercepts, testing for symmetry, and then plotting points. Okay, so if you were to graph this by finding intercepts first, to find an x-intercept, you let y be 0. To find a y-intercept, you let the x be 0. So let's let y be 0 first. So if you got 0 equals 1 over x here, you try and get that x on top, and you notice that 0 equals 1. This is not going to happen. You're not going to have an x-intercept here. Okay, 0 obviously cannot be 1. Okay, now we're going to see if there's a y-intercept by letting x be 0. We let x be 0, and we're like, hey, 1 divided by 0 can't divide by 0, so we have no y-intercept either. Let's go ahead and test this thing for symmetry. If I test it, is it symmetric with respect to the x-axis, then I'm going to let y be negative y. So here's my original. I'm going to let y be negative y. Take that negative to that other side there. Is that what I started with? No, it is not symmetric with respect to the x-axis. Is it symmetric with respect to the y-axis? This time we let x be negative x. Take that negative up top, and you test, and you say, is that the original 1 over x? No, it's not symmetric with respect to the y-axis either. Now is it symmetric with respect to the origin? So here's what we started with. We let y be negative y. We let x be negative x. We clean this up, so we got negative y equals negative 1 over x. Multiply both sides by negative 1. And that's what we started with. So this is symmetric with respect to the origin. With respect to the origin. So now, erase all this stuff here. Just get a little bit of room. Sorry about this. Now you just got to plot some points. So you throw some points in. Let's throw in like 1, 2, 3. Plot on 1 over. Let's put the 1 in first. 1 over 1 is 1. So you got 1 comma 1. Plug in 2. Now you got 1 over x. 1 over 2. Right. So we got a half. So at 2, x value of 2, we got the point, the y value of 1/2. So we're only up halfway. Halfway there. Oh, come on, darn thing. 2 comma half. Okay, plug in 3, and you're only up 1/3 of the way, 1/3. Plug in 4, and you're only up 1/4 of the way. And you can see this way we're going down. I didn't draw this very well. Oh, struggle with this electronic pen. Going down. Now I'm going to throw in like a half Let me throw in a half for my x value. So now what would I get? Y equals 1 over a half. And if I divide by a fraction, I can keep change flip. So that'll end up being y equals 2 here. So 1/2 comma 2. 1/2 comma 2. I could plug in a fourth and I'd get 4. So a fourth of the way to the right, and I'm up here at 4 now. I could keep graphing this, but what I'm going to see is this thing is shooting up as I approach 0. Okay, so this is my best efforts here at graphing this 1 over x. I do it on the left as well. Plug in -1. 1 over -1 is -1. -2. 1 over -2, -1/2. I graph that as well, and so on, and soon enough that you'll see when you start graphing this thing, you kind of get an idea of what this function looks like once you plot a bunch of points. And here's a much better look at that once you plot some, or plug in x values and it spits out your y values. Okay, and you notice 2 comma half, you'll have, since it's symmetric about the origin, you'll have -2 comma -1/2, and so on. So x, y will switch to -x, -y.